Hello, my name is Benjamin. I'm going to present how to architect Qubes OS with SaltStack and why it's easier than you may think. So what is going to be done? Why I think this talk is important. Like, for example, why backups don't fit this role, why shell scripts, they don't go well to manage infrastructure, and you should use proper infrastructure as code tools, how to architect using best practices, how to do basic salt states, and customize your states. The bad times when you have with Salt, contact, preferences, and Q&A session. So I'm a fast maintainer contributor. I like to automate every task. I like to do trail hikes and table tennis, and I have gear if anyone wants to play in the break. So the code is licensed AGPL 3.0 or later, and the documentation is CC by SA 4.0. So the code is used to fit the slides, else it would look too small in the slide format, and it's not a complete explanation on how to architect Qubes OS and use SaltStack, just the basics, just an intro. So I want to harden Qubes OS defaults. I understand why Qubes does what it does, because it can't be the most hardened and at the same time the most usable. And I would like to automate workflows between Qubes, because that's a nice, powerful feature of Qubes. It's the QRexec. And I want to replicate the setup easily on any machine, on my machine, on multiple machines of different people. So Salt is a configuration management system where you establish a state that you want your system to be. And it's also a distributed remote execution system where you execute commands and query data from minions. That's the Salt terminology, and we will call them target or cubes in this presentation. So some alternatives are Puppet and Chef. They don't have native integration in Qubes. Ansible, there was going to be a talk tomorrow, not anymore, unfortunately. And shell scripts, they are way out of the league. They don't fit, and if you try, I'm going to show it will be horrible. So Qubes has the powerful QRexec framework. It's a protocol, it's a client-server model. You may know on other systems as remote procedure call. It applies the principles of security such as usability, separation of duty, defense in depth, minimize attack surface. And the policy you may know on other systems as identity access management or ACL, but in this case, instead of users, it is Qubes itself, the name of the Qubes, and it applies principle of least privilege and secure by default, for example, not allowing connection to TCP ports to other Qubes, but allowing clipboard, copy and paste. And I like the Qubes philosophy of being open source and the security, because they focus on security and not other things. For example, for privacy, they let Unix handle with that. So what Qubes brings to the Salt execution, it is a master minion, so there is no connectivity to DOM0, and for that it uses a disposable management cube that it holds the Salt package and connector. You can see on this how it looks on normal system, and normally it is done with SSH, while on Qubes there's a target system where the state is copied from DOM0 and then to the target, and the target applies the state to, it is copied to the management cube, and the management cube applies the state to the target. And by this way, there's no way to, for example, to return escape characters to DOM0 directly, because they are sanitized by QRexec. So why automate? Because I think infrastructure replication should be done to always have a constant and consistent system on every machine, because backups are time-consuming and they don't aim to create a state. You just restore your old infrastructure, for example. And I consider SaltStack high readability. It uses the Qubes API, and it's built for dependency, where you apply a state and you can reapply it without a problem. You don't need to do logic to check if the state is not in that correct sense. Salt does that for you. And you can back up your state in code and not store, like, for example, template VMs and a lot of data that's not necessary. Of course, you should do backups for data that's important. And because automation is fun. What led to the status quo of shell script? I want to take some moment to that, because people still use it, unfortunately. I think it's both because most community guys, they use tutorials with shell scripts, and people try to improve upon that instead of changing to other tools such as Salt. So please meet John. He loves to manage his cubes with shell scripts, and he denies it is a double-edged sword, because he makes coding mistakes and the computer doesn't care what you think. It just returns the output. And then he complains to the forum, to the mailing list, to the GitHub issues. That's Qube's fault and not his fault to choosing the wrong tool. So Alice, she's been through that, and she wants to pass John, helps John pass through the grift. He'll go through, Salt has bugs also, it's Jinja bad, shell good, and no way, shell scripts rule, and okay, I'll use the Python API, I'll code directly in Python, and then after some time, we'll notice that's horrible because you're gonna have so much more things to think about and much more code to read and to understand. And most of all, I think it is not shareable, because if you share a Salt code compared to Python code, it's much easier to grasp the code reading in YAML than when it's read on Python. The same thing then, I hope John, through the end of this presentation, he accepted it's a better thing to do. I don't care if it's Salt, it could be Ansible, could be Puppet, could be Chef, but it needs to be something that's not shell scripts. So Alice lists some nice features to John, such as declarativeness, where you describe what you want your assistant to be, and you let the program handle the rest. And readability, where it's YAML and Jinja when necessary, and I also don't consider it readable, even though Python developers consider it and they wrote it, so yeah. In the content, you get consistent results focusing on achieving the same state, and imports, for example, you can, the same thing as you can source on a shell script, you can import other files, other formulas from yourself, from cubes, from whatever you want. And you can target different cubes by rows, regex in their names, and grains. Grains are important because they're properties that can only be cured after boot. But John thinks those are only fancy words. Yeah, so Alice sets a task to do in Salt and compare to shell scripts, such for example, install tunar and GDK pixbuff, and it must work on Debian and Fedora, and must only install the necessary packages. So this is how it would look like with shell scripts. First, there's no syntax highlighting. Second, you have to deal with quotes and variables only expanding inside the cube itself. And third, you have to understand how DNF and APT works. You have to search for the correct options to make it non-interactive. And the last thing, I think it's the most important one, with Salt, you have the result logged to Don zero, so you can see what happened, what failed, what version of the package was installed or uninstalled, for example. And this is how it would look like with Salt. The first part is the Jinja section, where you get the package depending on the OS family. So if it's Debian, it could be the Ubuntu. If it's Red Hat, it will also fit SUSE, for example. In the second block, you can see I'm calling the package installed Salt state module. I'm saying to skip the recommendations, skip suggestions. I have to use setup to install weak depths, because that's unfortunately something not supported by Salt by default. And then I get the previous variable package in the package section, and I put it to be called in the package list. And this output is logged to non-zero. You can see what happens. You can see how it goes, and you don't need to deal with quotes unless using Jinja. Yeah. But John wants another round. So they try again, but with creating a cube itself. Like, for example, creating the DVM browser, which is a template for disposable VMs based on Debian 12 XFCE, and it's labeled red. This is how it would look like with shell scripts, where you have to do a negating check if the cubes already exist, because if it doesn't exist, it will create successfully. But if it does exist, then you have a return code of 1 and non-zero exit code, and that's a problem. Then you check if the variables is already set to the desired value. Because if it's not, you have to set them. And then you have to do logic and if-else statements. And this section only is not bad, but imagine this multiplied into multiple cubes and multiple preferences, because this is only three preferences there. So it would look worse in a bigger scale. This is how it would look like with Salt. I call the KVM template installed Salt module, and I just say to Salt, guarantee the template is installed. It deals with the rest. Then the second section, I call the QVM VM Salt module. that is created by Qubes, so also the QVM template installed. I require the QVM ls installed Debian 12 XFC to have returned successfully. So I guarantee that this cube can only be created if the template of it exists. And then I set the preferences. I also set the present and the prefs double, the template and label, because I want to ensure it's on the correct state. The present is during the creation of the cube, and the preferences is after the creation of the cube itself. But okay, bored, already convinced, you already know Salt's better, but that depends on what you want to accomplish. Like I had a lot of ideas of what to present here, but I thought starting with the basics are the most important than trying to explain something very difficult that only a few people in this room would understand. So some steps that I think are necessary: design the architecture, set the rule for consistency, readability, and reusability. Those are things that you can find in the Clean Code book by Bob C. Martin. And also try it out multiple times, because you only get better after you try multiple times. So study Salt, Qubes OS, Target OS. You have to have an understanding of how it works. Else you will try to find how to deal with a problem that doesn't exist because you don't understand how the tools work. So read the manuals. Think how the tasks can be divided into multiple cubes, because that it is the cube's powerful statement. I want isolation, but I also want communication. And I lead, for example, the dangerous things to disposable cubes, and then return to app cubes, for example, to store data. Sketch or write freeform text, whatever you prefer, use on an online site, type on your computer, how this can be worked. Document your design choices, because you're going to forget. And then after you've done multiple formulas, your formulas will look like crazy, super different, so you have to document it. Declare the state and apply in test mode. It works to some extent, because other states may require the previous state to have a return value, and apply the state. And please note, this is independent of Salt. This is just architecture, so it could work with Ansible and other tools. So notice that template VMs are useful because you can have offline cubes based on it. Instead, when you have standalone VMs, it is difficult to install software when the standalone is offline, because you have to enable networking to it, install the software, disable. And with templates, you don't have this problem. You can use the proxy, for example. For user interaction, focus on using disposable VMs for data processing and app VMs for data storage. And the admin VM, has some usability, but not good enough. The QExec policy isn't restrictive enough to work in a multi-VM setup. For example, if I want a certain state to only be applied to certain cubes, that's limited on this case for QExec. Why? Because you can glance over the code and understand how it works. You don't need to spend a lot of time. If you know how one formula works, you can understand how every other formula works. Consistent names on the documentation, state declaration. Always declare your states the same format. Use macros, file hierarchy. Separates your states into directories. For example, use a files directory. For the admin states, put in admin directory. Make that something that you can understand and not have a lot of files, like 20, 30 files in the same directory. That will be hard. So, reviews. Macros and includes, because you're going to find code duplication, so you need to use macros in Salt, or at least it's better than have code duplication. CI/CD, it is kind of difficult. It's possible to lint, like for example, salt lint, pylint, shell check, but the problem is you need a Qubes workbench to lint your code, in the sense that you can test it also, and that is sometimes hard because you can write your code outside of Qubes, but you cannot test it. So this is a state module. As you can see on the second line, QVM template installed. This is a state module, a state that is inside the file, a module that is inside the state file. And the execution module is the state apply on the last line. It is a module that calls the previous salt file to execute it, everything. So you're going to be using both, and all the execution modules and state modules, there are many, but I'm just showing an example of how they work. now I picked this Alice. She's from the How to Organize Your Cubes, from the Qubes blog post. She has her workflow separated into multiple cubes for different clients, and she uses the client B code to write her code and client B build test to test her code. But copying one code every time she needs to test the Git repository from one cube to another, it takes a lot of time, and she wants to make it better. So she designs a system where the build code can fetch code from the client B code. Sorry, the build test code can fetch code from the client B code, but it cannot push it. And if you notice, I also use Alice also in the name instead of the default cubes, because you need to know from which source, from which origin your code comes from, because sometimes you can have formulas from multiple people and the service's name and policy could conflict, and that's not good. So I think it is better if you put your name, your company, or whatever, something that's informative to you. So this is the pseudocode all over it. Just to explain, the first file is the Git remote helper. Communicate using the Git remote helper protocol. The second is the QRexec service itself. And the third is the QRexec policy, where you can see the build code can only fetch the repository B from the client B code, but not from any other repository or from any other cube. Just so this is a state module, a state file. It calls the package installed, and it says to refresh. It says like package apt up to date, and it don't install unnecessary packages that can come with Git, and it install Gits at the end. That's simply it. But if you have multiple files, multiple packages, you would list them below Git. So remember the previous state, it is ls git install. You reference it via an include to not have code duplication. You set the Git execution path. It's different on different systems. You can also use another file from that. Just because of slide reasons, I put in the same. And then you install the remote helper. You require the Git was installed to not have any problems. You source from the SRV salt Alice path. And you can see the path is Alice files, Git client, Git remote QRexec. You set the mode. It's better to enforce the mode than let it be, and let the system choose the UMask. And set the user root and make directories. And it's also the same thing for the Git server. I just want to show through repetition that it is always the same thing for file management. Same thing for the Git policy. And I just want to make a note that you should not edit 30 user policy. That's very bad. Edit anything that's above it. Normally, the recommended 60 to 80. Yeah. So how would she apply those states? She calls the alice.git policy. You can notice that the dot is a salt nomenclature. It is also the path division in Unix, you'd know as slash. kubectl, state apply, and the path to the state that you want. And for in this case, for the DOM use, she applies to all the template. She skips down 0, and she lists the state separated by comma. But that is not good enough, because you don't want to list every time the states that you want to install and the cubes you want to apply them all. For example, if you have multiple states and multiple formulas, you can use a top file where you put a state in the high state. In this case, you'll see I'm matching DOM0 by node group, and I install ls-git policy to DOM0. While for the templates, that is a I-at, it is it's a pillar, it's a salt nomenclature for the cubes type template pillar. And if it matches the grains OS family of Debian or Red Hat, it's installed to those templates. Then you can see I enable the Alice to the high state, then I apply to every cube. So I don't need to worry about which cubes the person has in the system. I just apply to all, and the code is only going to be executed in the ones that matches the directive there, the high state. So, but the problem is Alice ends up producing many more formulas. In the first, it's Fedora 39, then later Fedora 40. And it's okay because it's 6 months. She will remember to update. No, she will not. When she has 50 formulas, she'll forget, of course. And she wants to do better, so Pillar Swift Ginger to the rescue. You can see the first part, it is a pillar. I declare the Alice template Fedora version is 40, and the same thing for Debian version 12. And I also use a top file to enable that pillar. So for example, if you have there a variable to declare, use pillar for that. You can enable customizability. For example, you can have a formula that when different people want a different setting for them, you can customize it by pillar. And now it looks ugly for me, but it is what it is. It is how Jinja works. You call the pillar get module of salt, and you declare the pillar that you want to get. And then after the comma, it is the default value if no value was received at all. And for example, I'm going to create a state to install Fedora, only Fedora in this case. I import the previous Jinja macro, not the macro, just Jinja statements. And then I use it using variables. So I only have to update one file or one pillar, for example, to have every other formula reuse it. But what would you, if you would create the previous Fedora, a cube based on Fedora, for example, the example cube itself, and I want to use the previous state Alice install Fedora, and I use also the variables again. This would not be necessary if I name my templates differently, such as template yellow, or something that doesn't contain the Fedora version in the name. So to enable the pillar itself, you put it in a high state, and you finish with pillar, the parameter pillar equals true. And then you apply the state that you want, and it will use the enabled pillars. And the properties will be enforced. So it installs Sunshine and Rainbows. OS support is not as good with Salt due to Fedora release cycle. So that's a very big problem when it occurs due to Python version. I believe Red Hat does better with Fedora and Ansible together because she collaborates on both. Troubleshooting syntax errors of Salt, it's horrible. Sometimes it indicates the line number and the column number, and when it doesn't, you are lost. Even if you fill in the file, it's not clear. Real-time output, Ansible has this one, Salt doesn't, because the output is only returned from the target after the call is finished. So, in summary, shell scripts are strongly discouraged. Don't bargain for infra, use the best tool available, use tested tools, don't use shell. Design and document the architecture before coding, be consistent throughout your designs, and you can only do that if you document your design, and apply best practices where you can on every step that is available, because it doesn't matter if you use Salt and you don't do a very good job at it, it doesn't matter at all, it's bad code in the end of the day. So I did something which is Qubes, Salt formulas for Qubes OS. Many of the things I would like to have shared here, but it simply doesn't fit the slide format, and people would not get it. So if someone wants to take a look, you can find on my GitHub that is going to be linked later on the references. This is my contact information. The references, I would also like to mention Uman, because most of the Qubes formulas in the beginning were based on Shaker, which he has been providing for free for the community for more than 2-3 years already. And Qubes is on the last link. So, any questions?
I have one question to one of the slides.
Yeah.
You showed the top file with targeting based on grains. This one. Does it actually work?
Yeah, I use it like this.
Okay, because I think we had some optimization to skip, to not apply to cubes that have no rules to apply, and to not even start this disposable VM. And I think DOM0 doesn't know grains, and especially this OS family of the target cubes. Maybe it works because it takes OS family of DOM0, which is always Red Hat. Maybe, I don't know, but it's interesting that it works.
I'm sure it was at least working like 2 or 3 months ago. I'm sure because I was using that, for example, and it would be skipped in Arch Linux.
Okay, so it was not, it was skipping Arch Linux, but no, interesting.
Some months ago, yeah.
Okay.
I don't know anymore. So
okay,
then.
interesting. Thanks.
Okay.
Okay, so yeah, I have a lot of that, but let's start with testimony. So thank you very much for this talk. Great talk. I'm using Kusal for I don't know, since it was published. It was published around a month after the Qubes OS Summit 2023.
Yeah.
So a month after my lame talk. Because this is wonderful thinking. So if someone will dive in the code and look at the architecture, it is really great. So thank you very much for that. It was source of inspiration and source of improving my own code and reproducibility of my own configuration. So yeah, but challenges. So I think like one challenge is tracking every modification. So for example, I have this situation that sometimes I want to try something, but I'm not sure if I will need that. So automating that at this point doesn't make sense. Yeah. So the question is how you deal with that.
I think for me it's not a matter of choice. I always choose to automate, because later on, like 6 months later, when you change your system, you're gonna forget. You're gonna have to find your nodes, and I prefer to document my nodes in code so I can just apply them. But it also depends. For example, when you cannot find a good way to code something that's like, for example, through a GUI, then there's no way. Then you have to do manually. But, yeah.
What about experimentation? Like if you want just like check something, what you do?
Check something like what?
Like a new tool which you don't know that you will have to install in future. Maybe you will check and you will decide, no, this is not it.
A new tool should be installed in a Qube, for example?
Yes, yes.
I normally start a disposable VMs, and if I have the code easily to be done, like for example, I copy previous formulas that I have, and I modify some things, and then I just target the disposable.
Okay.
So I don't have to worry about deleting the Qube after.
Okay, makes sense. How you deal with the DNS resolution, like when you want to firewall stuff? Because in Qubes, DNS resolution is like one thing, and there are many players who use. So, for example, I want to separate Spotify. I use Spotify, and yeah, but they use heavily CDN, and this is problem, yeah.
I don't deal with DNS on Qubes. It's difficult because NF tables is IP based. I don't have an example right now, but it's on my files. Like for example, the development Qube that I have, it has no NetVM, and it has a proxy to connect to Sysnet or Sysfirewall, for example, to have networking through SSH. So it's just an open port that's only available to github.com. So I can use the github.com DNS domain. But for example, for Spotify or Signal, which they use CDNs, I believe both, I don't have a solution right now. And there's other community options that I saw, such as DNS script, that you can limit based on the domain name. But I haven't tried them yet.
Okay. Yeah, what do you think? Like, is there any potential for the like this? If there will be this Qubes Air stuff with ability to remotely doing stuff, like what kind of potential you see with this? Is like could I, for example, manage all my fleet of devices, or like I don't know, maybe help others deploy things in a reasonably secure way?
I can imagine that. I'm eager to see the Qubes Air talk. Like for example, if you have connection to the Qube and you can execute commands on it through root, and you don't need the Salt connector because maybe it can be in the proxy and the proxy of the QXI connector, you can do remote Salt on that. So I believe it is going to be a good way to apply state to multiple Qubes that are not in front of you, and maybe a VPS, for example.
Mm-hmm. for some time I already have this idea of simplifying life for Qubes OS users in a way that, so for example, you have some workloads, anyone has some workload. Right now the workloads defined by Qube's team are like very kind of specific on the one side, but on the other side you can choose a lot. There's too much to choose, yeah, to be honest, and a lot you have to do yourself. But if you could have this kind of workloads defined in those Salt, the question is if this would make sense for Qubes to have this to just enable, like what, I don't know, I want signal, and I will correctly define signal VM, separated and so on and so on. Does it make sense to have in Qubes included that, or this always will be community part? You don't know.
I have a thought about, because I'm community, I'm not in the Qubes team. I understand why Qubes doesn't do it, because they don't have time.
Yeah.
Like there are many formulas available for some years, and even to review one state or two states, it takes time of them. So like maybe it will remain as community project. Maybe some things can be included on what they want to have basis instead of me proposing, because like I would like everything that I did. So yeah, maybe what they want I can try to merge upstream.
I'm already thinking about the market, yeah, because
we have this config repository where we have a bit relaxed policy what we can put there.
okay, so the problem is on auditing all that stuff, yeah.
Yeah, but we have like it's about trusting the author, so you install package only from the author you trust. So yeah, we don't provide any guarantee what's in this code. Besides that, we keep the integrity of the repository itself only.
Understood.
So yeah.
Okay. Okay. Thank you very much. Great talk.
Thank you.
There is one question from
To the mic, please.
can somebody read, because my power cable is not long enough.
Yeah, I'm just going to the matrix channel.
Okay, so the question from Magic is, where can you find guides for styling Yum and Jinja? You also talked about using salt linters. Can you expand a bit on that, please?
Where can I find guys for what?
Guides for Yum and Jinja.
Styling, YAML, and Jinja.
Guides for styling. I think on the internet yeah, really I don't have anything in mind, but for linters there's SaltLint, there's YAMLLint, there's PyLint when you use Python code, and try to find linters for everything you can so you avoid common mistakes. Yeah.
Hi there, I'm Corey with
Hi.
the Freedom of the Press Foundation. Thanks for your
Okay.
talk, Ben. The discussion that you've given on provisioning all these different kinds of resources and Peter's question about high-yield experimentation prompts me to ask, how do you deal with deleting things that have been configured this way? If you just remove them from the top file, Salt stops managing them, but the resources themselves don't go away.
Mm-hmm. I don't delete them.
Just
if it is there and
Yeah.
if I need to delete a cube, maybe I use QVM remove. There's like a state module for that where I can remove a full cube. But if I have, for example, modifications in DOM0, then you have to use the correct tools for itself. Just for example, file absent, that is the state module to delete a file, things like that.
Great, thanks.
Last question.
Hi. I was just wondering, is there a possibility to do like finer configs on the cubes, like installing a Flatpak or something like that, or executing commands, or is it mostly just provisioning these cubes with packages that are to be installed?
You can through the command run, for example, execute any shell command. So you can do that. I just didn't show any examples because that in one sense is like the prohibited salt module because it's not independent. But you could do any command, so just for example run Flatpak. Yeah. Okay.
Yes. Thank you.
Thank you.